Okay, let's carry on. So down here we see that they are actually asking for our understanding on the terms. So here we have a side view of the wave, and then here is what we call the wave front. So let's see, R will be definitely your wave front. S down here, basically this is a peak, this is another peak. So actually for your S, these actually represent your wave length. If we look at P, P is the distance between peak to another peak. So actually your P is also representing wave length. Down here Q, if you blow it up, you will be able to see that it is measuring from this dotted line is called the undisturbed position to the peak. So actually for your Q, it is actually your amplitude. So knowing all these terms, we can now look at the options given. Wavefront. Wavefront is given by R. Yeah, and that's it, right? So we have R. And then if we look at wavelength, wavelength is given by P. It is also given by S. So P, P. So this means that A must be my answer. Okay, carry on. Let's look at question 17. Question 17 is a displacement time graph, and we talk about it over here. So in a displacement time graph, what happens is that displacement time graph, we can actually find the period, right? We can actually find the period. Okay, so if you see there's one wave, it takes 3 seconds, then it is the period. So let's look at this. Okay, so where is one wave? One wave actually is from here. This is half a wave, one full wave. So you can see that to make one full wave, you will need 2 seconds. So if your period is 2 seconds, then your frequency is given by 1 over t, which is 1 over 2, which is 0.5. So answer is B. Okay, when you look at question 18, again, they are checking your understanding on the terms. So what is measured by meter? And you know that meter is actually a unit for your length. So amplitude is a length, frequency is in hertz, speed is actually meter per second, wave length is of course the length. So of course, 1 and 4. Okay, let's carry on. Here in question 19, I can see that there are 2 waves. One is displacement distance graph, the other is displacement time graph. So if you look at here, you can see that if it is displacement time graph, you can actually get the time graph. Displacement time graph, you can actually get the period, and if it is a displacement distance or displacement position graph, you are actually getting the wavelength. So let's see what we are getting. So down here, displacement distance graph, you can see that one wave will occupy 2 cm. So this is your wave length. Okay, down here you can see that one wave will take 0.04 seconds. So you know that the period is 0.04 seconds. And if you convert it into frequency, it will be 1 divided by 0.04 hertz. So now you are supposed to find the speed. Speed is given by V equals to F lambda. F we have already found out is 1 over 0.04, and that your lambda is 2. So if you solve this, you will be able to get the answer. Okay, for question 20, again, this is about graphs. So this is a displacement distance graph. You are able to find the displacement distance graph. You are able to find the wavelength. Yeah, so what is the wavelength from here to here? This is one wave, and the length is 400 mm. Right? Then the question is asking you about wavelength. So your wavelength will be 400, right? The other thing you need to find is amplitude. Remember, amplitude is from the top to the equilibrium position. So actually this is your amplitude. So it is 10. So this is your answer. Yeah? Okay, question 21. A wave passed along a spring. Which statement about the period? Period is, can you recall? What is the meaning of period? Period is the time. Okay, period is the time taken to make a wave. So let's look at the option. Hertz, this is for frequency. It is definitely not for period. The number of oscillation per second, yes. If you know the number of wave made in 1 second, you will also know the number of oscillation made in 1 second. So this is correct. Let's look at C as well. It is the speed divided by wavelength. So what is the speed formula? V equals to F lambda. The speed is given by this. Wavelength is given by this. So let's make it speed divided by lambda. That will give you frequency. Okay, is the time taken for one oscillation? Oh, this is the correct answer. I'm so sorry, this is wrong. The number of oscillation in 1 second, this is your frequency again. I am so sorry. Yeah, so D is your correct answer, the time taken for one oscillation. We are at question 22. So as you can see, question 22 onwards involve many EM spectrum. So EM spectrum is all transverse wave. The most highest frequency would be your gamma ray. Okay, so let's take a look at this. So in the first sequence here, you can see that they purposely change. So down here is actually, it starts with the low frequency and it ends up here with the highest frequency. So if you recall, Gorilla X urinate violently in my room. So radio wave is actually the lowest. The highest frequency down here, this guy, is actually your gamma ray. So gamma ray, followed by X-ray, followed by ultraviolet ray, so U. So your Q here will be your U. Then you will have visible light, and then you will have infrared ray. So this I stands for infrared, so it has to be for this guy, and yep, so A will be your answer. Okay, next question. Again, I am talking about the EM spectrum. So Gorilla X urinate violently in my room. Yeah, V stands for visible light. So what is I? I would be infrared. So which row show the property of W? All EM spectrum is actually your transverse wave. Yeah, I already said many times. L wave, longitudinal wave, there are two. Sound wave and your slinky if you push it back and forth. Then after that, I have to compare with the speed in vacuum. So for the EM spectrum, why is it that they all these gamma ray, X-ray, ultraviolet, why are they all in the same family? Well, because they all travel at the same speed in vacuum. So C is your answer. Okay, next question. Which row describe the property of electromagnetic wave? That is your EM wave. All of them are transverse, and the speed in vacuum is actually the same. They travel at 3 times 10 to the power of 8. This is your speed of light in vacuum. Question 25. Visible light and gamma ray, they are both waves. Which row are correct? Well, visible light, of course, is transverse. Gamma ray is also transverse. Like I said many times, your only longitudinal wave are sound wave and slinky when you push it back and forth. Question is on sound. Okay, so again, you can see that there's a frequency of 256 Hertz. Like I said many times, what is the meaning of frequency? Can you recall what is the meaning of frequency? Yeah, frequency is the number of waves it produces in 1 second. So if you have 256 Hertz, it means there are 256 waves produced in 1 second. So let's look at ABCD. So A, 256 cm long, no. 256 Hertz are not length. So by the same logic, wavelength is not measured in Hertz. It produces sound wave, no, 256 is not a speed, and yeah, it vibrates that many times, because each time it vibrates, it will produce a wave. So if you say that there are 256 waves produced in 1 second, it also means that it vibrates 256 times. Okay, 28, waveform of two different sounds. So sound, we describe sound in terms of two things. the pitch and the volume. So the pitch is controlled by frequency, whereas the volume is controlled by its amplitude. So now I have to compare this with this. So you can see that if I look at the amplitude, it's about the same. So I would say that they are as loud as each other. They are not louder or quieter than one another. You can also see that within 1, 2, 3, 4, 5, 6, 7, within 7 boxes, I can see there's 1, 2.5. So 2.5 wave in 1, 2, 3, 4, 5, 6, 7 in 7 boxes. Down here, 1, 2, 3, 4, 5, 6, 7 in 7 boxes. I would have 1, 2, 3, 4, 5. So I have 5 waves in 7 boxes. Then definitely my sound 1 will have a higher frequency. My sound 2 has a lower frequency, and so sound 2 has a lower pitch than sound 1. Okay, question 29 is about sound again, but this time round is about echo. Okay, so basically when you fire a gun at X, there will be sound producing in all directions. So in this case, we are interested in these 2 directions, one here, and you are standing at Y. So when you are standing at Y, you will first hear this sound because it is nearest to you. The second sound that you are hearing is actually the sound that travels here, reflect at this point, and then it bounces at you. So because the total distance traveled is longer, you will hear this particular pink color sound at a later time. Yeah, so now you need to find out what is the interval. So let's find out. So the speed of sound is actually 300. Let's find out how much time is taken for the sound to travel from X to Y over this path. Okay, so to do that, time for path number 1 would be equals to distance divided by the speed, which is cancel. This is 3, this is 6, so it will be 0.5 seconds. Now, when the sound go by this path, let's call this path number 2. So time number 2 is given by a total distance of 300. Speed is 300, so time 2 will be 1 second. So the sound from here to here, so this one, the green path, if the sound go by the green path, it will take 0.5 seconds. If the sound go by the pink path, it will take 1 second. So what is the interval? Interval means the difference will be 1 minus 0.5, right? So 1 minus 0.5 will give you 0.5. This will be your answer. Okay, question 30 again is about sound. So sound wave, like I said, we have 2 things to describe it: the volume and the pitch. Volume is given by amplitude, pitch is given by frequency. So down here you can see that they have the same frequency, meaning that they are having the same loudness. Yeah, and you can see that down here there's only 1 wave in 4 boxes, whereas here there are 2 waves in 4 boxes. So I know that this guy, sound wave number 2, will have a higher frequency, so they will have different pitch. Yeah, in fact 2 will be higher pitch than 1. Okay, then we have this weird looking waveform. So what happened is that you have 2 different sounds. I think this would be 1 sound, then after that this will be a second sound. So you can see that the first sound P will be louder because it has a higher amplitude. So this is amplitude for P, and then this is amplitude for Q. Yeah, so definitely P is higher than Q, so P is louder. Which one has a lower pitch? Lower pitch meaning that the frequency is lower. So frequency is lower, P is frequency lower. You can see that 2 wave, it occupied such a big time. But whereas for Q, 2 wave is just from here to here. So we say that P actually has a lower pitch. So A is your answer.